Okay, so we are continuing our lessons on the slopes of parallel and perpendicular lines, but now we're kind of going further with them and talking about their entire equations. So we're going to look at this example where we are looking at what they're saying is a grind rail for a skateboard, and we get this graph, and you can look down here to number 6, and it says here that the drafter has already drawn line N. And next, the drafter needs to draw line P so that it's parallel to line N and passes through the point -2, 3. And so ultimately, we're looking to draw a line that's parallel to N. N is already, right here. And we're looking to draw something that is parallel to it that goes through the point -2, 3. So the first thing that it asks is, what is the slope of line P? So as I look at line P, there are a couple different ways to look at this. I prefer, personally, to make sure that we use this point. If you look at this, it's definitely going through 0, 2. And so if I go from here, I'm rising 1, and I am running 8. So I'm rising 1, running 8. We know that it's positive. So the slope of this is simply 1/8. Okay, the slope is 1/8. And then part B says, what is the equation of line P written in point slope form? So we just talked, we did one example of point slope form. So I'm going to start our point slope form here by simply writing what point slope form is. Y minus y1. This is the equation for point slope form, equals m times x minus x1. And we've been doing a lot of these where we have had x1 and y1, and the idea here is understanding that we're going to plug things in to the y1 and the x1. And also, the reason it's called point slope is because this is extremely useful when we get a point and a slope. So in this case, we happen to have both those things. We have a point. We know that it's going to go through this point, -2, 3. And we have a slope, 1/8. So we're going to use those two things. We're going to use the point, -2, 3. And we're going to use the slope, 1/8. And so since we're using this point, we're going to call the -2, 3. That's my x1 and my y1. And we're just going to plug those values in. So in this case, y minus y1, we're going to plug in 3 because that's what my y1 is. For our m, we're going to plug in the slope, and you'll see here that it says m equals 1/8. And x minus x1, in this case, this is x minus the -2, which we've seen a lot of. We're going to say x plus 2. And that's it. That is the equation in point slope form. It's a really, really convenient way to write an equation when I happen to know a point and a slope. It's a really convenient way to do it. Now, this next thing is asking us to now write this equation in slope-intercept form. The other thing that's convenient about this is just the ability to take this equation and convert it to slope-intercept. So we are going to convert it by solving for y. So typically this is just a couple of steps, okay? And so the first thing I'm going to do here is actually distribute the 1/8. So we get y minus 3 equals 1/8 x, and then 1/8 times 2 is 2/8, which also reduces to 1/4 as a fraction. And then my last step is to get y by itself, is to add 3 to both sides. And there are a couple ways to write this, but we're going to get ultimately y equals 1/8 x. And then we have 1/4 plus 3. There are a couple ways to write that. I think right now I'm actually going to say it's 3 1/4, just because I think that's convenient for what we're doing in this particular case. You could also write it as 1/8 x plus 13/4. I just feel like in this case, the 3 1/4 is actually a little bit more helpful to graph our line. So then part D is asking us to sketch line P. I actually want to go back to really the beginning, because the ability to sketch this was actually really convenient from the get-go. We were told that there's a point at -2, 3, which is right here, right? And then we're told that the slope is 1/8. And so because we know that, we can go up 1/8. We can also do the same thing over here, creating 3 points, and we're simply just going to take this and make a line through the 3 points. And that's not as good as I'd like it to be. Let's try again. That's a little better. You can see that looks to be parallel, right? And we know that this is line P. We're going to label it as line P. And so we're able to not just say what the slopes are, but we're able to put this in all kinds of forms. So we're able to put this in point slope form and ultimately slope intercept form as well. All right, so now we're going to continue this, but this time we are looking not at something perpendicular. So it says here that next the drafter needs to draw line Q so that it is perpendicular to line N, perpendicular, and passes through the point -9, 7. So it asks, what is the slope of line Q? Well, our original slope was 1/8. This is not the answer. And so what we need to be able to do to the 1/8, remember that a perpendicular slope is the opposite reciprocal, right? It's the opposite reciprocal. So the opposite of reciprocal of 1/8 is simply to, first of all, make it negative, right? Because the other one is positive. That's the opposite part. And then the reciprocal part is to say that it is 8/1. We flip the fraction. However, I don't have to write 8/1. So we're just going to say that the slope is automatically -8. So once again, we're asked to put this in point slope form. Y minus y1 equals m times x minus x1. Again, you'll see that from that first problem, we happen to know what a point is, a single point, which is right here, -9.7. And we know what the slope is, which is right here, -8. So I'm going to go ahead and write this. It's y minus y1. In this case, my y1 is 7. That's up here, right? My slope is -8. And this is going to be x minus x1. And again, that's a negative number, so this is going to be x plus 9. This is point slope form. It's one sort of step. And keep in mind, we can already draw this, right? Like, we have the ability to draw this from what we've done here. We are going to convert this to slope intercept form. Same sort of thing we did before. Really, the only difference in this problem than the first is that we ended up having to change the slope to the perpendicular slope. So again, the first thing we're going to do here is distribute on the right side. So we get -8 times x, which is -8x. -8 times 9 is minus 72. And our last step to get y by itself is to add 7 to each side. And we end up with y equals -8x minus 65. Okay? Now, it turns out that equation is not all that convenient to graph. Okay? However, we know a point and we know a slope, right? And because we know those things, we go back to our graph that we started here. We know that there's a point at -9, 7, which is right here. We know the slope is -8. So since the slope is -8, I'm actually going to go down 8 in this case. I'm going to go down 8, which is this far, and then over 1 because it is negative, and I should have a point here. And I'm just going to connect those two. And And so what we happen to know because of these 2 points is this is absolutely a right angle. We made this to be perpendicular, so that is a right angle. In fact, this is also a right angle that we happen to know is true because of the way that we created these. See you guys next time.